Hi all, welcome to our next session of ML course. So in this session we are going to see the basics of probability theory. So have you ever wondered how AI is making predictions? So here is the answer. It all starts with the probability theory. So that is understanding the uncertainty. Probability theory deals with understanding the uncertainty in artificial intelligence, or we can say probability theory that helps in understanding the uncertainty in ML. So here we see the importance of probability in ML. So probability helps in handling uncertainty, and that probability is essential for data modeling. That uncertainty can be modeled, or using this probability we are studying the patterns. The learning patterns is done using probability, and that is used for AI driven decision making. That is used for predictions in ML and AI models. So we can see an example. Here we can see flight delay. Flight delay in some cases that is affected by weather as well as the airline traffic. That is, if the weather is bad, flight will be delayed. There is a probability of flight delay. And if the airline traffic is high, again, there is a probability of flight delay. And if the conditions are just the opposite, good weather and less airline traffic, there are less chances of flight delay. That is, this probability, whether it can happen or not, that is predicted using the basics of probability theory. So what is probability? So here we can see the definition of probability. That is a measure of uncertainty. Probability can be defined as a measure of uncertainty that quantifies how likely an event can occur. That is the probability of something that ranges between 0 and 1. 0 means the event is almost not possible. It's impossible to happen. And 1 means the event is certain, 100% chance of occurring an event. That means the probability is 1. So if for an event A, if something is occurring, that event A is occurring, the probability of occurring of event A is calculated as number of favorable outcomes divided by total number of possible outcomes. So here an example, coin toss. Coin toss, we can say if when a coin is tossed, we can have two outcomes. One can be head, the other can be tail. So probability of head, that is given by number of favorable outcome is 1 divided by possible outcomes, that is 2. So the answer is 0.5. Similarly, the probability of tail is also 1 by 2, that is 0.5. Okay. So we can see some terms used in probability. They are continuous. The first term is random variables. Random variables means it's a numerical value. We are assigning a numerical value to each outcome of a random experiment. We are assigning a particular numerical value to each outcome of a random experiment that are known as random variables. The random variables can be of two types. It can be discrete as well as continuous. It can be discrete or continuous. So discrete random variables means they take countable values. It can be finite or infinite, but it is always countable. Separate values results from counting. So it is defined, the probability, the random variables in the case of discrete case. Discrete random variables are defined using probability mass function. So then next is an example of discrete random variable. That is, as we have already said, it is countable. If you are rolling a dice, what are the possible outcomes? The possible outcomes will be 1, 2, 3, 4, 5 or 6. So the probability of x is equal to 3. The probability of getting 3 as an outcome, that is given by possible outcome is 1 and the total number of outcomes is 6. So it is 1 by 6. I hope this is clear to you. Next is continuous random variables. So continuous random variable means it takes uncountable values. That is the possible values within a given range. So that is results from measurement. It is defined by probability density function. So we have seen discrete case, it's defined by probability mass function. And continuous random variables is defined by probability density function instead of probability mass function. So example, temperature of a city or height of students in a class. So the height of students in a class, they are all measured by continuous random variables. So here the point is that for continuous random variables, probability of an exact value. So in this example, if you see probability of 25, that is equal to 0. But you can see the probability of x lying between 23 and 24. Like that we can write. So we are calculating probabilities like this in the case of continuous random variables. So the next main terms we are going to learn in probability. Before that, we can see what are the real world applications in machine learning of this discrete and random variables. So spam classification, this is an example of discrete. Then fraud detection. In the case of continuous, it can be image processing, speech recognition. Okay, all these comes under examples of machine learning using, that is under the discrete and continuous variables, random variables. Okay, so the next term we are going to study is the conditional probability and Bayes theorem. So what is conditional probability? Conditional probability measures the probability of an event occurring given another event has already occurred. That is probability of A given B. That is B has already occurred. That is what this denotes. That is given by probability of event A occurring given that B has already occurred. That is given by probability of A and B divided by probability of B. So here example is given by a box has 3 red and 5 blue balls. So probability of A, that is picking a red ball, that has already occurred. So if red ball is already occurred, the number of red balls remaining will be 2 and the number of total balls remaining will be 7. So probability of B, picking another red ball, that is the second red ball, is given by 2 divided by 7. Okay, that is an example of conditional probability. Then next term is the Bayes theorem. So Bayes theorem is used to update probabilities based on new information, that is the updated probabilities, that is defined using the Bayes theorem. So here probability of AB, that is posterior probability, that means the updated probability after B. Then next one is probability of B given A is true. Okay, then the initial probability of A and the probability of B. So that is for updating probabilities you are using the Bayes theorem. So we can see this with an example. So example of a medical testing. So here we can see 1% has a rare disease, that is probability of A. That is initial probability of A before seeing B. Whatever be the B value, 1% of population has rare disease, that is 0.01. Then probability of B given A, that is probability of B occurring given A is true. If 1% has a disease, test correctly detects 95% at the time. That is if 0.01% or 1% has a disease, then the test correctly detects 95% of the time. That is probability of B given A. So we have seen probability of A and B given A. Then the other part, that is probability of B given negative of A, that will be 100 minus 95, that is 5%. Using these values, we can calculate the probability that a person actually has disease, give the positive results. The person that actually has a disease give the positive result. That is the updated probability after the evidence of B. Okay, probability of B occurring given A is true, that is given by 0.05. So we can find probability of A given B. That is probability of this B given A times probability of A divided by probability of B. Okay. So the applications of this Bayes theorem and conditional probability, that is as we have seen in medical test, we can say first application we can write it as medical test. Then fraud detection based on unusual behavior. If something unusual occur, we can detect the fraudulent transactions. Then updating probabilities of spoken words based on prior words. And use data to determine email is spam based on the words used. The method used here is naive Bayes classifier that we can see in detail in the coming sessions. And some more terms that are related to machine learning probability, that is the expectation and variance used in machine learning. So what do you mean by expectation? That is actually known as the mean value or the average value. Represents the average or expected outcome of a random variable. Average value of a random variable. That is what is known as expectation or mean. So we can see some definitions for discrete random variable and the continuous random variable expectation. The expectation in the case of a discrete random variable, that is given by summation of, you can see all the possible values of x times the probability of x. All the possible values of x multiplied the probabilities, we are adding it. Here it is the summation. We are adding all these things to get the expectation in the case of discrete random variable. And what comes in the continuous random variable, instead of summation, this will be integration. integration of the probability density function. You can see in continuous case we are always using the probability density function. Okay. Then the second term associated with machine learning probability, that is the variance. Variance actually is a measure of spread, that is how deviated is the value from its average value. Measures the spread of a random variable from its mean, or it's the expectation or average value. How deviates its value is from the expectation. So for example, we can say clear example is stock price predictions using machine learning. And we might have heard about the term standard deviation, that is the square root of variance. So next we can see different probability distribution functions in machine learning. So the different probability distribution functions are Gaussian distribution, Bernoulli distribution, Poisson's distribution, etc. We can see in detail the Gaussian distribution and all we can see in detail in the coming sessions. So for ML ideas and concepts, you can subscribe the channel and like the video if it was useful to you. Thank you.